Some students struggle with domain and range. All right, so an inverse relation is if the original relation pairs A of the domain with B of its range, what the inverse does is it switches the domain and the range. So it pairs B with A. So the domain is now what the range was, and range is the domain. We're going to take a look at both them as coordinates, them as equations, and them as graphs. Question 1a asks us to find the inverse of relation M. So for the inverse, all we have to do is switch around the x and the y. Now you still leave the letters x and y, you just switch out what the numbers are. So this would become -2, -1, -1, -2, and they also want us to graph both of them on the same graph. So I'm going to let a solid point represent the relation M, and then I'm going to let an x represent the inverse. So instead of putting a dot, I'll put little x's so you can see the difference. It's hard to tell what's what on a graph. So let's graph M itself first. So regular M would be -1, -2, 0, -1, 1, -1, and 2, -2. Don't connect the dots because they didn't tell us we should. This is just a set of ordered pairs. Now, for the inverse, we're going to plot these points. We'll use little x's. So -2, -1. -1, 0. -1, +1. And -2, +2. And they want us to describe how the line y equals x is related to the graphs of M and its inverse. So let's graph the line y equals x. Technically, y equals 1x plus 0. Slope-intercept form. So graph that, and we'll just put a dashed line because it doesn't actually exist. So start at 0, up 1/1, up 1/1, up 1/1. How does that line relate to M and its inverse? What's the relationship between them? Abby?
It flips over the line, the inverse.
Good, it flips over the line. So that's called a line of symmetry. Okay, so it's going to be reflecting. I'm going to type this out. So my handwriting is inspired. Points are reflected across it. And that's something that's going to be useful when we start graphing them on Monday. If you know the original function, you will actually not have to figure out what it is. You'll just be able to reflect the points across that line and come up with the graph of the inverse. They also ask us, are they functions? How do we test if something's a function? Caleb? Vertical line test. or you look at the x values and make sure they don't repeat, right? So looking at m, if we do the vertical line test, yes, it is a function. It only touches one point at a time. Now, is the inverse of m a function? No, it would fail right here. So we're going to learn something on the back called the horizontal line test, which is something you can use for the inverse of a function to test. For the next two, we aren't given a graph, we're given an equation. You want us to find the inverse of the relation given the equation. All you have to do this is you interchange x and y, so you switch the variables, and then you solve for y. So step one, switch x and y. We kind of did this in geometry with trig, inverse trig, where we switched. So this will become x equals y squared minus 2. Solve for y now, using inverse operations. What would I have to do first to start solving that for y? Jade? Add 2. What would I have to do next? Caleb? Take the square root. Now, remember, when we insert a square root symbol, we also have to insert a plus or minus. So the y squared and the y cancel. So we'll get y equals positive or negative square root of x plus 2. Put in your notes. Do not forget. Because you'll only have half of the graph, half of the function. Then they ask us, does the original equation, y equals x squared minus 2, is that a function? So if you think about this as a graph, x squared minus 2 makes what shape? Quadratics. Actually, parabola. So this would be like shifted down to, which isn't really important, but something like this. So would this pass the vertical line test? Yes. So the original function is a function. Now the inverse, and you guys don't know what these look like yet, so let's take a look with our graphing calculators. Remember, they are going to be reflected about the line y equals x, but let's take a look graphically. So go to your y equals button, clear out anything you have in there. Now, you cannot put in a plus or a minus, so we're actually going to have to do one positive and one negative. Okay, so a y1 and a y2. So we'll have the square root of x plus 2 and y1, and then we'll have negative the square root of x plus 2. And go ahead and press zoom 6, which is zoom standard. Like a sideways parabola, right? The graph well. Would that be a function? Fails the vertical line test. So, if you don't want to have to think about the graphs of each of them and do the vertical line test, you can use something called the horizontal line test. The horizontal line test is used on the original function, and it will tell you whether the inverse is a function as well. So just like we do the vertical line test, you'll draw horizontal lines. So if the horizontal line only touches at one point, then the inverse will be a function. If it touches at more than one point, then the inverse is not. So let's go back. If I use the horizontal line test on the original, see how it would fail? Which is going to tell you that this is not a function. So it's something that tells you about the inverse without having to graph the inverse. You don't have to use it if you don't like it.
Is it always going to be opposite, like if the real function is?
No. No, they could both be functions. If they were both linear, they will both be functions. Good question. All right, so down here, find the inverse. And is the inverse a function? So remember, to find the inverse, we're going to swap our variables around and then solve for y. So this will become x equals 3y minus 2. Now we have to solve this for y. So we will add 10 to both sides. And we will divide by 3. Now make sure you do divide the whole left side by 3, not just one of the terms. So we would get y equals 1/3 x plus 10/3. So that's my inverse. And then it's up to you whether you want to use the horizontal line test with the original function. Some students don't like that. They just like to think about the final function and do the vertical line test, whichever you like. If you look at the original one would be a linear function. So if you do the horizontal line test, it would pass. So that means this is yes, a function. If you prefer, look at this one. This would also still be a linear function. It would pass the vertical line test, which would tell you, yes, it is a function. All right, then the next two will be a little bit harder because of the squared. Again, switch your variables. What I do first is start solving for y. No. He said expand. If you expand, you're actually going to get y squared minus 10y plus 25, and you'll have two y's. It's harder to solve for y when you have two of them than if you have one. So that would just make it a little bit harder. Abby? Good. We're going to undo a square with a square root. As soon as we insert that symbol, we need a plus or minus. So we'll have plus or minus square root of x equals y minus 5. And then we'll add 5. Do not put the 5 under the radical. It's outside. So our final answer will be y equals plus or minus the square root of x plus 5 outside. Is that going to be a function? The original one is a quadratic, which would be like this. So if you want to test the original, you'll use the horizontal line test. It fails the horizontal line test, which means this is not a function. If you prefer, think about the graph of this one, which would be something like this. And it would fail the vertical line test, so you would still see no. So it's up to you whether you want to use the horizontal or the vertical on the final. So you guys can try number 9 on your own. The last two are graphically. So we're going to be given the inverse, or given the function, and asked to graph the function itself and its inverse. So one way is you can graph the function itself and then reflect each point across the line y equals x, like we saw in the front. Or, so circle the word or. Some students don't like reflecting. They don't understand like how to count diagonally. And it'll be up to you whether you like it or not. You can also just list the coordinates, like a little XY table. Pick some points that would be on the function. And then for the inverse, all you'll do is switch them and then plot them. This is more work, kind of, but some students really prefer it over the other. All right, now do we remember how to graph quadratics? That's the question. What's the negative in front, tell me? It's going down. What's the minus 2? Left 2, right 2, up 2, down 2. Down 2. So normally it starts at 0, 0. So we're going to go down 2. And then we would go down 1 over 1, down 1 backwards 1. Will get us 1 point. The other ones aren't going to fit on the graph. Now, if you want, let's suppose you don't remember how to graph quadratics. You can just pick some points, plug them in algebraically, and figure out what the points are. So like 0 squared minus 2 is negative 2. 1 squared is 1. Negative 1 minus 2 is negative 3, and you can see that's what I got here. And then make sure when you do the 2, this is negative parenthesis 2 squared. So this would be negative 4 minus 2, which will get you negative 6, but that's going to go off my graph. Now we do want to connect the dots because this is the equation. So that's the original. Now for the inverse, it's up to you. If you did the table, all you have to do is flip these around. This will become negative 2, 0, negative 3, 1, and negative 6, 2. And then you'll plot those and connect them. If you don't want to do it that way, you can draw in the line y equals x. And you can reflect each point across it. So, if you notice this point is one diagonal space away from the line, so you would go one additional diagonal space continuing across. This one goes one diagonal space across, we go one diagonal space across. Now this is where it gets a little hard. This goes 1, 2, so we'll go 1, 2. Again, some of you will see that visually, you're cool with it. Some of you will hate that and have no idea how I counted this. So if you're one of those people, do this method. But you should have both equations correct. Now the next one's going to be a little harder because they're both going to be linear. So the original function is negative 5 up 3 over 1. And again, if you want to do your table of values, we'd have 0, negative. And then if you're liking method 2, you just switch these around. And then plot them. If you prefer the graphical method, this one's a little bit tricky. It's not terrible. So reflect out a half space, 1.5 spaces, 1 spaces. Then this one actually goes backwards. Okay, so on your homework you'll have some where you have to graph both of them. If you want, you can use different colors, but you can actually tell which one's which. Or you can just do the X's to help differentiate. Your homework is a worksheet